Welcome, everybody. Today, news item for infrastructure was I thought we could go back and revisit the California issue a little bit. I know 2 weeks back we talked about the 2 canal systems, and there are some conflicts between different water users and how the policies and trade and all those things were playing in. But then the central question remained that we were relying on this infrastructure that was carrying water from one region to another, and it's now failing in quotes, not because of the failure of the system itself, but then we don't have enough water. And what do you do when you don't have enough water? You build another system, right? Which is what this new news item is all about. So there's this company that wants to build a new water conveyance system that moves water from one region to Southern California. And I thought I couldn't find a video that was covering the entire issue in like 2 minutes. So I just found a video that the company put out themselves saying how great their project is. So I thought we'll look at it and I'll share some more details. Okay. Right, stop. Oh, wait. Okay.
You gotta put the volume on. Top right.
Cadiz is a renewable resource company located approximately 100 miles east of Los Angeles. We have 2 things in abundance: sunshine and water. Cadiz has the largest agricultural operation in San Bernardino County. We presently grow organic dried-on-the-vine raisins, row crops, and lemons. The Cadiz aquifer system is roughly the size of Lake Mead, the nation's largest surface storage reservoir.
We decided to participate in the Cadiz project because it's a known supply. The key to the Cadiz project is that it's local water, it's available, it's conservation.
The Cadiz project means additional reliability for our customers and businesses in Southern California.
Our project will capture groundwater, which would otherwise evaporate.
The Cadiz project, which has a safe yield of 50,000 acre-feet per year, can serve several 100,000 people.
This well field will extract the groundwater and place it into a pipeline, which will run parallel to an existing railway line, and then ultimately be distributed into the Colorado River Aqueduct. The water will be transferred through existing infrastructure to customers throughout Southern California.
The supply in California is in crisis.
California is famous or infamous for either we get a lot of rain or no rain. What we need to do to get past the boom and bust cycle is to develop a local supply resource like Cadiz. The Cadiz project's environmentally sustainable because it's in a closed system aquifer, and we're using water that's otherwise lost to evaporation.
Cadiz is presently engaged in an environmental review of the project, which is open, public, and transparent. We're committed to protecting the desert ecosystem.
In my professional opinion, I think the science here is state-of-the-art.
We executed a green compact which would preserve large quantities of land to permanent open space and hold open the opportunity for solar power development. Nearly 5,900 jobs will be created by this project.
The Cadiz project will support the California economy, particularly in Southern California, and it is an environmentally sustainable supply.
Groundwater quality is excellent. It has a total solids of about 200 to 300 parts per million.
This water is high in quality, high in reliability, making it one of the most important elements of a water supply portfolio for Southern California.
Any resource can be misused, but I think this one is very vast, and I think if it's used in a sensible manner, it should be sustainable indefinitely.
Where's it coming from? Alright, so that was pretty convincing pitch. Especially like the guy sitting in the suit.
The tree, did they say where it was coming from?
No, they didn't exactly say, so I'm going to tell you that.
Yeah.
So, before we even...
Yeah, that's right.
Okay. Before we go into the project a little bit, I just thought I found this map, which is again from the same company. It's on their website. It shows a list of water conveyance projects in California. And I was just amazed looking at the network of systems. Any way I can make this bigger? Okay, so this is California with all the rivers and the major rivers and the conveyance systems. I'm not sure if you can see the differentiation in the colors. So there is a canal system here. There is the Hetchy Aqueduct, which supplies water to San Francisco. Although with the reservoir that's not going to be there, they're planning to remove the dam. So I don't know what happens to this system and how they get their water from now on. That's one system. Then you have the much bigger California Aqueduct, also called the State Water Project, which gets water from all this delta region down to Southern California. And you would also notice that the San Joaquin River actually flows the other way. So this is again flowing against the gradient. So it has to go up, this huge hill. And then of course there is the LA Aqueduct, which supplies water specifically to Los Angeles. And not to be out on the Colorado River Aqueduct, which supplies water from the Colorado River to the Southern California. So now this system is based somewhere here, I guess. Somewhere here, in the Mojave Desert. Somewhere here, I guess. That's my approximate location. And so they will supply, they'll tap water from the Mojave Desert underground aquifer and then construct a pipeline that connects to the aqueduct here. So there is a little bit of new construction and then the water will join this existing system and then it will flow to Southern California. I mean, the project itself might be, pretty standard California project, I guess, but then there are a lot of specifics. So I read this news article from Bloomberg Business Week, and that had like a lot of interesting information on how this company has, its sole mission is tapping this groundwater, nothing else. They're not like a water supply management company. This is their sole business plan. They've been in existence for 30 years. They've not made a profit in 24 years. But they have some big investors. So more than the project, I'm actually surprised by the, I guess business smarts of the people who are involved in putting money behind this project. And a lot of the local governments actually agreed and signed contracts with them, but then there's a lot of public opposition, as you can imagine. And their bigger project before that, so this is one of their more recent projects that they are now pushing. The one before that was to store the excess water from the Colorado River during seasons when there was enough water, and then store it on land that they had bought, and then sell it to municipalities during drought. Obviously that never happened because there was never enough water in the Colorado River. So that never happened, but then they had signed these agreements with the metropolitan water districts and things like that. But after a point that wasn't going through, so they had to reinvent themselves. So this is their plan. I just found this whole thing pretty fascinating.
So I've seen plans like this for Peru, so that, because there's a lot of investors all over the world who are kind of
Right.
interested in this kind of stuff, and I assume it's similar to what I've seen for Peru, because you're in the desert, so LA, Southern California, but so the water presumably is coming from the Sierra Nevadas there, I assume. So,
I mean,
that's where it has to come.
it's
As they showed the things, there were no plants growing there, so there's no water that comes there.
right, but this is from the aquifer, underground aquifer.
Right, but the water is being.
It's come from somewhere, but
It's
yeah.
being recharged by the mountains.
Oh, right,
So
okay.
this is the big thing. I mean, though, at least when I saw this with some of the big, big venture capital funds who were thinking of investing in this area in Peru. I mean, it's understanding the geology well enough of these aquifers to say, are they really sustainable? Because it's a complex system where water is entering the groundwater higher up in the Sierras, and the
But
rate
the-
at which it enters and which it recharges.
Right,
is
but so
really-
their argument essentially is we will take water at a rate that's faster than what it normally recharges, but
But they don't know what it normally recharges.
no, but yeah, so and they're using an argument that this water typically overflows into some dry lake and evaporates. So that's why he says
Yeah.
it's better than evaporation, because they are making the argument that it flows into some dry lakes, and so
Right,
they
and-
will essentially prevent that from happening by tapping off this extra water, and then the aquifer will automatically keep recharging.
Right, so the whole thing comes down to who were the scientists involved in doing these measurements?
We saw the guy.
No, one guy from the University of Texas, right. And how often does it overflow in the dry lakes, and how much, and what's the historic record on this?
Right. Right, so, I mean.
So that's what you need to convince, well, if you're an investor and you're gonna just go for it, you might be able to do that without that data. But if you were an environmentalist and you said, oh, well, this is gonna be sustainable, you wanna have estimates of all that. And those are not easy. I can tell you in Peru, it was really difficult to decide, you know, whether these aquifers, if you started pumping them down,
Mhm.
how fast they were gonna recharge. So.
It's not easy.
As you know, how much, even if they were gonna look at Dryden and look at putting in
No,
another
that's-
well, and how much study they'd have to do
Right,
to get
right.
it that.
So, anyway, so this was the news item. Are there any questions or points that you wanted to discuss? Outside the unknown geology of underground aquifers?
I'm impressed that so many people are buying into it.
Sure, a lot of local governments, and I mean, they have spent a lot of money on lobbying. They had, at various points, they had the governors of California, the mayor of LA, like the Secretary of Interior, former Secretary of Interior. They're all either on board as directors or they were lobbied actively by those people. So, I mean, they have had, you know, they've spent their money wisely in some way. Yeah.
Do you know who else uses the water in that area of this aquifer? Are people using it?
So much of the land is part of the national park system, and there are some local tribes there. It's part of the Mojave Desert, so they have, I think.
But they would have to own the surface rights, right?
Right, so the national park owns some of it, so that's why they are involved, and so they were asked for some comments. So it's a pretty intricate system with federal lands, some, I guess, tribal land ownership there, but much of it is under the federal government, and I guess they'll have to get rights at some point.
Yeah, they would. But I don't know what the California groundwater law.
Right, and these guys own a lot of land, and they started. I mean, he talked about some lemons and blueberries or something. I think they were growing that initially, and then they gave up on that, and they decided this was their sole mission.
It's a
Which is why
bigger-
they're preserving the desert.
Yeah, I mean, the bigger problem in my mind for California is like probably what, 90%, 95% of the water goes to agriculture, and half of that goes to grow alfalfa to feed their cows, half of it. So if they just reduced their alfalfa growing by 20%, they wouldn't have nearly the water problems.
Right, but then we saw the guy with the, the previous video 2 weeks ago talking about how it affects China and all that.
Right,
so
exactly, right.
We'll move on to today's talk. Actually, we don't have the speaker today. If you look at your schedule, Mildred Warner was supposed to speak. It was going to be a nice shift from the engineering, natural sciences to the social science a little bit. So instead, we have our very own Brian, who will speak today. So it's a nice bridge. He sort of sits at the middle spot there. Yeah, right. So let me introduce Dr. Brian Rahm. He is a research associate here at the Water Resource Institute. Got his PhD from Cornell University, and has worked in different places in New Zealand, New York City, and back here. I thought I should make some formal, attempt at introducing you. And he has essentially two options for talks, and he wants to leave that up to you.
Yeah.
So, on to you.
All right, so class gets to choose what we hear about today. Two pretty different topics, both having to do with, at least to some degree, water, wastewater infrastructure. So topic number one, is going to be could be about Marcellus Shale, everybody's favorite. That's four. Or we could talk about a watershed-based approach to assessing infrastructure, with the primary focus of the Hudson River Valley, the Hudson Estuary. It's not really estuary, but the Hudson watershed, including the Mohawk, which, if you don't know, is the large river that essentially goes past New York City. It takes up about a fifth of the state. So those are the two topics. How many people want to hear about Marcellus Shale and all of the water-related stuff that goes with that? Right. Does that mean that other people want to hear about watershed-based assessments? Okay. That's good. I was ready to talk about either one, but to be honest, the shale stuff, I feel like talk about that too much. Okay. There. All right. Before we get into this, though, I did want to ask, since Mildred had to sort of back out, I thought it might be a good time. Does anybody have any questions or comments from any of the previous speakers, like thoughts or questions that have come up in the preceding weeks? Anything they want to talk about from Monroe, Ruth, who else? Todd, Rebecca, Jerry? Is that it?
I think
Yeah.
you did.
Nothing? We're good? Okay. Any other just general thoughts, infrastructure news you might have seen in the last week or two? Anything else that you think has been interesting? I know I'm not going to probably nobody's going to say anything, but I'm just figured it'd be a good time to.
The Columbia webinar?
Right. Okay. Yes. Thank you. So I posted that on Blackboard. If you want to see it, I might just be able to. No, I just closed it. Okay. Well, I closed it. But the Earth Institute at Columbia is going to have a webinar on. Do you remember the title?
It basically just has to do with aging water infrastructure and what we're going to do to deal with that.
Okay.
And there's a bunch of different panelists.
Was that March 14th?
I think it's the 21st.
Okay.
So it's next
It's coming up.
Thursday.
And if you want more information on
Friday.
it, you go on Blackboard. It's a webinar that probably is going to deal with a lot of the things we've been talking about. And I think you might have to register for it, but it's not like, I don't think it's going to cost any money or anything like that. So if you want to listen in, check out Blackboard. All right. Okay, so no random conversation about infrastructure. Then we can get into this. Assessing wastewater infrastructure using a watershed scale goals approach. Well, as we go through the talk, I'll explain what that all really means. What's important here really is just this map that shows the region of New York State that we're going to actually be talking about. So if you're not familiar, New York City's down here, you have Long Island. The state comes up here. This is what people from New York City call upstate. This is really upstate. Albany would be right about here, okay? And the Hudson estuary, because it's tidal, so it'll be salt water will come in up to actually, I forgot exactly where they say the salt front moves to, but
Poughkeepsie?
Poughkeepsie.
yeah, it's quite far up. So Poughkeepsie, which I believe is, I'm going to randomly kind of pick somewhere in here. So this is the Hudson watershed. It also includes the Mohawk, which drains into the Hudson, but has some unique issues associated with it. So this is the area that we'll be talking about.
So those are all individual watersheds
Yeah.
that feed into?
Yeah, good question. So these are the names of what we'll just say are smaller watersheds that all collectively will make up the Hudson. Some of them have names of actual rivers that are there, and some of them are just, the Middle Hudson sort of encompasses a number of different watersheds. So the idea will be, which we'll get into, was if we look at infrastructure, particularly wastewater infrastructure, assessing that on these regional, on a basis of these particular regions here, not the entire thing by itself, but also not on each individual project level or each facility level. Like what happens if we look at these, at this level of scale, this scale. Okay. Why are we concerned about infrastructure? I think we covered a lot of this in previous talks, and particularly maybe in the first week where we tried to sort of lay the foundation for the entire semester for this class. But why are we worried about infrastructure? It's like, well, there's a large need. When it comes to gray infrastructure, particularly with wastewater, this is for wastewater only. In New York, it's predicted that we'll need $36 billion over 20 years in order to either repair or replace wastewater infrastructure just for New York. If you throw in water supply, so water treatment, not just wastewater treatment, that number bumps up, it roughly doubles. So we're talking about $60 billion. So big numbers. Whether those are exactly right doesn't really matter. The point is, there's a lot of money. Over the same period of time, and if you go back to when the Clean Water Act was enacted in the late 70s, the federal funding for these types of projects has been reduced by 70%, at least through the Clean Water Act. There may be other mechanisms, but the idea is that assistance, at least from the federal government, is declining and has been for quite some time for these types of projects. Third sort of justification is water quality impact. A report that came out from the New York State Department of Environmental Conservation, which I'm just going to say DEC from now on, looked at 30-year trends in stream water quality, and they determined by their work that 24% of the declines that they saw, so not every place declined in quality, but some places did, and when they did, 24% of those were due to organic wastes and or municipal and industrial inputs. So things related to infrastructure. Okay, so what does New York generally do about this? Well, they have essentially a couple different options, and all of them, the main ones really work through this program, which is an EPA established program. It's called the Clean Water State Revolving Fund, funding framework, a little bit of awkward title. And what that does is it provides a mechanism by which federal assistance can come down to the state level and actually fund these different projects. So again, if Ithaca wastewater treatment plant needed an upgrade and they were looking for assistance, they would potentially go through the Clean Water State Revolving Fund, get the money, and then do the work that was needed. So for New York, the DEC actually runs essentially the Clean Water State Revolving Fund. Really, it's a company called the Environmental Facilities Corporation, but they're pretty closely linked. That's how New York runs this revolving fund. And part of the reason is because New York has primacy when it comes to these types of issues. If you're not familiar with what primacy is, a lot of times the EPA establishes these big programs that are meant to ultimately, for example, this program comes down to like a municipality who needs money for a very particular project. But a lot of times the EPA doesn't even really want to have to manage all of those projects through all of the states. As a state, you can elect to take primacy of that program, which basically means that you'll agree to take responsibility and manage all the different things that go along with that. So when it comes to these types of things, New York has primacy. Not all states do. So for example, sometimes you'll see the EPA taking sort of direct regulatory action when it comes to even individual facilities, but then in other places like New York, the DEC, for example, will be more heavily involved, and EPA is just kind of, it seems like EPA is kind of out there, hands off, but it's just because New York has primacy. And just to clarify too, if anybody has any questions as I'm going here, I'd like to make it as conversational as possible. So just feel free to butt in with thoughts and any potential confusion. Okay, so in the EPA's funding framework, in other words, how should we get money to people who need it for these projects? There are two different options, okay? Option number one is that a state like New York can develop an integrated state priority system, which essentially means that they come up with some way of looking at projects and prioritizing, this is the most important one, this is the next most important one, etc., on and on and on. Okay, New York uses alternative number one, and they use it, this is a picture of their intended use plan. I actually have a hard copy of one of them. This is a draft intended use plan from 2002. I'll actually hand this out here. If you look at it, what it does is it explains what the state revolving fund is. It explains how New York is going to use it, and then it goes on to give you the list of projects in priority order, and there's lots of them. And in the back, just in case you're interested, I know you're not going to read the whole thing right now, but it actually shows the ranking system. In other words, like how exactly did they score these projects in order to give them the place that they did. So, and 1 second. I thought I had it in here. Oh yeah, here it is. City of Ithaca is actually in here. It's got 2 projects on the list. Both of them look like they're estimated to require $754,000. They got a score of 41 out of several thousand, so that's not so good. I'll just let you take a look at it. Even just sometimes it's interesting to look at all the different projects, where they come from. You can see, for example, if you run into a page where the New York City projects come up, like suddenly we're talking about tens of millions of dollars per project, and so it's a lot of money proposed to be spent in there. Lauren.
In calling that an integrated system, is that just meaning they're looking at the state as a whole and basically ranking everything?
I'm not sure what they define as being integrated, but I think that when you look at the way, for example, that New York chooses to prioritize their projects, which has nothing to do with this title necessarily, it's that they're trying to take into account, for example, financial need of communities. Like, can a community pay for its project?
Because these are mainly loans, right, Brian?
These are loans. These are low interest loans. They used to be grants. They're now low interest loans. So they'll take into account a number of different things. Like, sure, the project has to have an identified outcome that seems beneficial to water quality in particular. But then there are also things like the community's ability to pay for it, which might, if they can't pay for it, it might bump them up on the score a little bit.
I think there are some scores for environmental justice if you have a underserved community that could benefit from this project.
But I think that's where the integrated idea comes. They're trying to account for more than just the engineering. So whether they do a good job of that is, somewhat debatable. But I mean, it's all right there if you want to see how they score it. It is transparent. So okay, now actually we're not going to talk about this at all. Okay, we're going to talk about alternative number 2, which I don't know. Can you guys see that? Is that kind of in the way? So alternative number 2, which essentially no states use. Nobody uses this alternative. Everybody uses alternative number 1. Now in part because alternative number 1 is somewhat, I'm not going to say it's easy, but I'll say it's relatively easy to justify. You say, we're going to give out points, and here's how. You submit your project, we grade it, and then we hand out money according to your grade. Everybody kind of likes that idea, they're comfortable with it. Alternative number 2 is to have a goals approach, which they say could be statewide or watershed-based. Nobody really knows what this means in practice. So what we're going to talk about is, well, what could that mean, again, for the Hudson watershed? So in particular, the reason why we're interested in this is because as you look at the IUP, for example, you'll see, and I don't know how many there are, but there's probably 500 projects or more in the IUP, and not all of them are going to get funding. So there's, in fact, probably less than half of them are going to get funded. So there's a much greater need than there is money to pay for those projects. So what we're interested in is, could we do this a better way in terms of, for the amount of money that we spend, could we maximize the benefit? Since we know we're not going to be able to fund everybody, we can't be perfect, but maybe we could do better than just ranking each project and saying, okay, well this one here, that one over there, this one over here, because it might be possible, for example, to have synergies between projects. 2 projects might be not necessarily working together, but they might be coming together to sort of attack a single goal, for example. Okay. Right. This is another interesting thing that came to our attention as we were thinking about this type of stuff. Just another reason to start to think about, what does it mean to try to efficiently use limited funding to create the maximum amount of benefit for these types of projects? New York State passed the Smart Growth Public Infrastructure Policy Act. This was in, I'm gonna say 2010?
Yeah.
Yeah, so 2010, there's a lot of words. No state infrastructure agency shall approve, undertake, support, or finance a public infrastructure project, blah, 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 to the extent practical, unless it is consistent with the relevant criteria of smart growth, which it then actually delineates. What does smart growth mean as far as New York is concerned legally? Right here. And again, we're not going to get into it because there's a whole bunch of stuff, but you know, you can see, you can get the flavor. So to advance projects for the use, maintenance, or improvement of existing infrastructure. So rather than build something brand new, they're trying to say, why don't we incentivize working with stuff that already exists? Does that make sense? Does it not make sense? Doesn't matter, because this is now, you know, New York's law. So the EFC, the Environmental Finance Corporation, Facilities Corporation, so many acronyms, has to abide by this law. So and it's unclear, although it's becoming more clear because they have now smart growth guidance in their IUP. Like, how will the EFC include these types of criteria when they rank their projects? So we just think it's interesting. It's not totally clear where that's going, but we're sort of actively researching this now. Right. Okay. So what does it all mean for us? When it comes to a watershed, we thought that, for example, when you remember that map, if you're way up in the north part, that probably means you're essentially in the Adirondack Mountains, very low population, very rural, not a lot of cities, very different watershed goals than, for example, if you're in New York City or Yonkers or whatever. Totally different infrastructure systems, very different populations. People are concerned about different things. They have different abilities to pay. All sorts of stuff is very different. And so we were thinking that if you were to have a goal in terms of what you're trying to accomplish with infrastructure, it's actually going to completely be different depending on where you are. So a goals approach, I'm not saying a statewide goals approach would be a bad idea. We just haven't really looked at that or thought about it too much. We decided to start with, what does it mean to have a watershed goal approach? And that could be totally different. For example, if you're up in the Adirondacks, you may be really focused on tributary protection, so protecting the streams and the water quality in the streams. You might want to minimize things like engineered infrastructure. You really depend on ecosystem services. That could mean tourism, fishing, and things like that. And that, you know, the ecosystem and the benefits that it provides really are linked to your social and economic priorities for that area. That might be very different, for example, than a watershed that has an urban development type goal, where you're essentially, you know you're going to continue to really build in this urban space. You may want to incentivize infill. Ecosystem services really don't cover it. You know, you're not going to treat your wastewater from New York City by building a wetland. It's just not going to happen. So you may be replacing those ecosystem services with centralized engineering infrastructure and looking to sort of get economies of scale when it comes to paying for those types of things because you have so many people in such a small space. We're not saying these are the goals, but these were the goals that we're going to continue to talk about through this presentation. Probably if you're going to really enact this in practice, you would think a little harder, or you would think a little differently. Not that we didn't think hard. You would think a little differently about the particular goals that you were going to apply to each watershed. So it's really, it's a thought exercise. Okay, so what did we actually do? We did a regional wastewater inventory. It's just wastewater, so it's a little bit limited, but in the context of the Clean Water State Revolving Fund, it's actually, you know, it's applicable. And we did it, again, by watershed. So here you see a bad picture of the middle Hudson. The actual Hudson River flows through the center here. So it's not a true watershed because it has watersheds on each side branching off. Each green dot is a wastewater treatment facility. So you can see there's a bunch of them in here. And these are all the different stream systems that we looked at within this watershed. The colors denote water quality as assessed by the DVC. So, again, what we're trying to do is see if we could look at some of these watershed type goals and maybe try to put together a sense of, do those goals really fit for each watershed? Is there a goal that we should be applying to a watershed that may make more sense relative to other goals? And we did that with a bunch of different data. These are the different sources that we use, some federal, some state, some we just call people on the phone. So we have some descriptive data, for example, where's the facility, what's its permit number, design flow of the facilities, the actual flow, in terms of how much wastewater is it treating. Is it a combined sewer system? Is it not a combined sewer system? What's the population that system serves? What's the receiving body of water that actually takes that discharge? And how is that body of water doing? What are its, what is its water quality, and how is that being impacted? So all sorts of different stuff went into this inventory. And we were trying to come up with some fun ways of representing this information. And this is one of them. So what we basically did is we took all this data about wastewater treatment systems, the populations that they serve, and the water bodies that they discharge into, and we tried to come up with these metrics that basically said something interesting about that system, about that watershed. And then we mapped them. So this metric we're going to call excess capacity. What it's essentially trying to show is if you add up all the different facilities, remember we were looking at the Middle Hudson before, if you add up all the different facilities and you look at how much wastewater are they designed to treat versus how much wastewater they actually treat, is there room there to actually assimilate a greater population in the future? So essentially what we're saying is, are you at the limit of your treatment capabilities right now, just purely volumetrically? We're not even asking if the plant works right, we're just saying, is it big enough? Now we play with the numbers a little bit, and what we have here, this doesn't actually relate to size. We basically said that if the population in the Middle Hudson, for example, were to grow in the future the same way it's been growing over the last 10 years, how long before that watershed runs out of wastewater treatment capacity? Does that make sense, everybody? So essentially, if there's no shading, if you're up here, you're really not worried about capacity because you're not even adding population. So you have a completely different problem. If you're really darkly shaded, for example, that's a little bit confusing. Forget these up here for now. If you're really darkly shaded, like the Mohawk, for example, it means that given your current population growth, you're not going to run out of space for like 200 years. So you at least have enough facility space to handle the population. But if you're down here in like the Wappinger or the Rondout, you may actually have only a few decades of space left, which essentially means that you better start thinking about building some new treatment plants because you're running out of room. So some have extra capacity, some have just low growth or no growth, which is actually a pretty different problem. And some of them have really high population growth and are running out of room really fast. Anybody have any questions about this?
You may want to mention that this is an average and specific individual facilities might be then running out of.
Right.
Okay.
Okay. So what this is saying is, all right, I know there's a lot of stuff here. Try and get through it. This is essentially a graph that tries to show you, for example, in the Hoosick, I think it's just best to use an example. In the Hoosick, okay, this which is here, it looks like you've got a really long time before you use up that capacity, over 200 years at the current population growth rate. So you could say like, well, not a problem then. The Hoosick doesn't need to worry about wastewater infrastructure for another 200 years. The only issue with that is that almost like 84% of that capacity exists in a single facility. So if you don't live within, the sewer shed of that single facility, it's pretty irrelevant whether or not it has space for you or not. Now, some places have really distributed space when it comes to where is the actual space. So the Rhondda and Wappinger are pretty distributed. The only problem is they're running out, their entire region is running out. It just so happens that they're all running out equally. Whereas when you get down into here, like the lower Hudson, for example, this is almost all Yonkers, which is one of the biggest treatment plants around, until you get into New York City. This does not take into account New York City, just to say that. So it's essentially a skew. It's like how local of a problem is this versus how regional of a problem is it? Yeah.
How, do you have any sense of how much growth there is in like municipalities where there's wastewater treatment versus areas where people are on septic? Because like, I grew up in Orange County and like, I feel like, there's just so many developments coming that would be mostly on septic, taking over, these former farms where it's like pretty sparse development, and that's a pretty big part of growth too.
We've seen, I don't know exactly, but we've seen, for example, that if you look at new facilities being built in New York over the last even 40 years, 30 to 40 years, they're almost all really small. Sometimes only serving 200 families, 200 households. The kind of small where you would start to think, why are they building a facility? That seems like it should be septic, which we'll talk about later. But so they are quite small, and I think you have to get into this discussion of like, well, how small is too small? Or should you have just connected it to a larger facility? And if that wasn't possible, should you be developing there?
Right, because isn't that part of the idea of smart growth?
Yeah, is that smart growth?
You don't want all these little things scattered all over the landscape.
Chelsea, looks like you have a question.
Well, I was remembering, I was recalling looking up statistics on how many POTWs of a certain size there were once, and noticing that small developments, like the one that Lauren is talking about, were putting in individual systems for their like neighborhood that they were building.
Right.
And I feel like that was because of some regulations that pushed developers towards
Toward
building a
building their
treatment
own.
system versus septic.
You mean privately owned?
Yeah, privately owned.
There's not that many
treatment
privately
systems?
owned, treatment facilities, like at a trailer park or something.
Well, we wouldn't have seen them here because we wouldn't have
They're
looked for them.
They're not recorded
Although,
very
well, we
but-
recorded Speedy's numbers though, so we would have seen that they were, usually though, the private ones are industrial. So you
Yeah.
can tell by the name that it's some sort of industrial facility that's treating the water. But you might be right. I think the idea that like, what incentivizes developers to either connect or stay separate? Because they have those types of things where like, okay, you can build this development, but you've also got to pay for the connection infrastructure. Maybe that's the rule.
Well, yeah, the connection, but they don't have to pay for the wastewater treatment plant.
Sure, but I'm just saying
That's what-
there are rules that
Right.
say like, okay, if you want to build 100 houses up on West Hill, go for it. But you've also got to build the sewer. We're not going to build it for you.
Well, yeah, except that's really hard to
That's the
implement.
opposite of what you're saying.
Yeah, and actually what I've said, I think I mentioned that too, it's really hard to implement in the state of New York.
Sure.
It's very hard, maybe only one or two municipalities, this one that's outside of Albany, I can't remember the name, but had enough kind of smart planners and lawyers to be able to do that. Because you can't require anything of any one developer that you're not requiring of all developers. But in the case, I think the thing is for building municipal wastewater treatment plant, there's just a huge incentive on the part of developers to put political pressure on the municipality to build because it so increases the value of their property. As opposed, so if they're gonna build a development with 100 homes or something, if they can get that hooked up to municipal wastewater treatment plant, it's just gonna make the value of the development much higher. So, and if there isn't one there, they're gonna push oftentimes to have that done, which is, I think, why you see all these small.
Yeah. We'd be interested though if you find something about that dynamic between developers and treatment plants.
And the case to look at is Lansing, because they've just gone through that, a big struggle. But they basically seem to have voted it down.
I was looking at this years ago, so I probably,
I don't know.
I'm probably recalling it incorrectly, but
So here's another metric. This has to do with septics, okay? So exactly what we were just talking about. Like maybe it makes sense, maybe it doesn't make sense to build a facility there at all. Maybe you should be using a septic field or some form of decentralized wastewater treatment system, more like what Ruth was talking about during the second week there. So again, by region, we looked at soil suitability for septic systems. So in order to have a really well-running septic, you've got to have the right soil types. You can't just put it anywhere. I mean, you can, but then it won't run that well.
Or it's real expensive.
Yeah, so the places where you see, again, darker shading is good, because what that means is that you've got, for example, in the darkest shading, greater than 34% of the soils in this area are either not limiting or somewhat limiting when it comes to septic development. So this might be, in these areas where there's dark shading, might be a good place where you could incentivize septic as opposed to a wastewater treatment plant. What's the problem with this area down here? Yeah, I mean, it's so heavily populated that there's no way they're going to really rely on septic as a rule.
Although if you move up Westchester, they have a lot of septic.
There it does get somewhat sparse. So this is just one other idea to sort of combine, and we'll get into the combination in a minute.
What did
Yep.
POTW stand for?
Publicly owned treatment works. Yeah, it's annoying that there's so many acronyms that all say the same thing, like WWTPs, wastewater treatment plant. There's even other things like WCPC or some waste control processing facility. It's like, I don't even know what the difference is. There might not be any. Okay, there's also a stream water quality assessment metric, and there's a bunch of metrics that I'm not going to show. This looks at wastewater treatment plant violations. So if a wastewater treatment plant, for example, trying to think of they release, the water's really cloudy. It's not supposed to be cloudy. They release a bunch of really turbid water. It's got high total dissolved solids, TDS, or something else like that, and maybe they released too much organic material, that'd be BOD, biological oxygen demand, doesn't matter. If they did something that they shouldn't have, and they released something that they shouldn't have, they get a violation usually. Now, sometimes the stream, so for example, if you were to see the streams coming through here, and you looked at like a treatment plant, I don't know, I like drawing things, so if this is the treatment plant here, and it discharges into the stream that goes by, you know, maybe the treatment plant discharges way too much total dissolved solids, so sediment. But the stream doesn't really have any problems with TDS, so that doesn't ultimately become an issue. I mean, unless it keeps on doing it over and over and over in really large loads, it may not be an issue for this stream that's happening. The problem is that when this stream has been determined to be impaired by TDS, and then you have this issue where the wastewater treatment plant is actually part of the problem that we've already identified with this stream. That's what this metric is trying to say. What it's saying is that in darkly shaded areas, the things that the treatment plants do poorly at also are what the streams are impaired for. Does that make sense? Okay. It's not as if there aren't violations in these other areas. There are. It's just that the kinds of things that the wastewater treatment plants are doing badly don't seem to be impacting the streams necessarily, according to the DEC.
So what's happening in the Mohawk?
Sediment, TDS.
Oh, TDS.
Yeah. Usually. So, I forgot, I'm just going to throw out some random number, don't quote me, but like, the Mohawk enters the Hudson, and you know, this is essentially the Mohawk here, just these two darkly shaded portions, plus this little guy.
That's
you know,
the Schoharie.
Yeah, but it's in the Mohawk.
Yeah, it's in the
So, you know, so it's not as big as the rest of the area, but it contributes like a majority of the total dissolved solids, the sediments in the Hudson that make their way into the estuary, come from the Mohawk. And part of that is natural. It's supposed to do that. That's the way those rivers are. But some of it is actually also because of the treatment facilities. Maybe because of infill or inflow and infiltration and things like that. But it's hard to say. Okay. Any questions on this one? All right, we'll just do one more metric real fast. This one will get into funding. So what's happened here is if you're darkly shaded, it means that you have asked for a lot of money compared to how many people you actually serve. So these wastewater treatment facilities in the Mohawk, for example, every year they're on that IUP list, wherever it is. They're asking for millions and millions and millions of dollars relative to the number of people that are going to benefit from those projects. Now it's a little bit hard to tell why, for example, the Middle Hudson is relatively lower in terms of the amount of money per population that they've been asking for. Maybe they're just really bad at asking for money. So there's a lot of reasons why this may or may not be completely accurate, but the idea was, are we spending the money equitably in some ways? So are we spending all of our money in one place, even though not very many people are benefiting, or is it being spread out pretty well throughout the watershed?
When you said, what was the per capita thing? It's the number of people living inside of that watershed, or you said the number of people benefiting?
Number of people served by the facilities who are asking for the money.
Okay.
Yep. So if you have a facility that's not asking for money, like for example, like the big facility in the Hoosick, if they're not asking for any money, you're not going to score high on this metric because that's probably where all the people are. So that's the idea. Yep.
I guess I'm curious what the point of this metric is, because the treatment plant is still important, right? I mean, no matter how many
Sure.
people are served, and so if it fails, it's still a problem.
Yes. I think there's a couple of things that we wanted to at least raise with this. One is there almost always is some attempt to spread the money around. Whether we think that makes for the best projects or not is not, that happens. And we're trying to see like, well, is that happening or not happening? The other thing might be sort of it's not necessarily willingness to pay, but you might look at some of these places and you might say, like, is there something wrong with the way you're managing? Because we seem to be dumping a lot of money in, and or it may indicate a place where you don't have the population anymore to manage the size of the facilities that you've got.
So is this money that they actually received, or this is just what they've asked?
This is what they've asked for. So again, it's not a perfect metric. Yeah. For a lot of those reasons, those are good reasons why this is not. This should only be like the beginning of a conversation, and nobody should walk away and say, "Oh, like that means the Mohawk's terrible at blank." But it's just the idea is that we're going to put all those metrics together, the ones I showed you plus a bunch that I didn't show you, and we're going to say, okay, well, how do they rank in terms of how they do on those things? And it's a bit of a relative scale for each metric. That's why we had the shading. So, for example, if you were the darkly shaded region for one metric, it's like you scored a 5. And if you were shaded white, you got a 0 or a 1. So it was an ordinal scale. We try to put together different metrics. And you can say things like, you can look at growth capacity, that first metric that I showed you. You might say that someplace like the Upper Hudson, maybe on one extreme of the scale, because they're not even growing, so their population is in decline. That might be a very different type of problem than if you're growing too much. Whereas if you're in the Lower Hudson, it's a little bit interesting because even though there's a lot of people there, you also have a lot of high excess capacity of supportable growth in a few facilities at least. So the idea was we put all these metrics together and we started to score them. This is this is the part of the process that's a little hard to explain to people in just like 5 minutes. But what we basically said was for each of those 3 goals, so let's say we're talking about tributary protection, right? We basically said, and help me along here, Sri, if you can, if tributary protection is your goal, which it might be if you're like up in the Adirondacks, you are looking for, or at least you're prioritizing certain results when it comes to certain metrics. You may, for example, maybe you don't want any gray infrastructure, so you want suitable soil for septics. Perhaps also you don't want to build new infrastructure So you want either excess capacity or I'm trying to think of one of the other metrics that help to explain this. Maybe you want to minimize the impact that your facilities actually have on stream water quality, so you want that violations metric to be sort of low. Because the quality of the water in the river is actually important to your overall economy, it's important to your overall sort of cultural, the way that you see yourself. It's not necessarily the case in New York City, for example, or Westchester. It's not that they think, New York, we have the worst water, it's awesome. But they're not thinking that, but I think that for an average New Yorker, down in the city, they're not saying like we've got the best trout streams of any 10 million person city in the world. This is not really part of their thinking. So they're not going to necessarily prioritize the idea that violations are matching up with the water quality impacts. So what happened? What should smart growth mean, for example, by watershed? So again, this is what we found. If you're in the upper Hudson, and this one's a little bit intuitive because again, you're pretty much up in the mountains here. They scored the highest for this tributary protection goal, which to us meant that this is probably what you should be going for if you're the upper Hudson. You may want to maintain your existing infrastructure, but you don't want to build new stuff. Way up here, where there's really they're not growing. There's not a lot of people there, so you don't want to start building a whole bunch of new stuff. There was a link between the water quality investment and the regional economy and social values in the sense that they don't want their facilities impacting their water quality, in that they prioritize that perhaps more than other places might. This was also a place where there was maybe limited impact on downstream water quality. So for example, what happens up here doesn't really impact necessarily what happens down on the coast as much as someplace like the Mohawk might. Because the issues down here aren't related to what's happening up here. I mean, it is, but I'm just saying the reality is that what's coming out of the wastewater treatment plants in the upper Hudson are not the types of problems that you see down here. That is happening in other places. Okay. Perhaps not surprisingly, the lower Hudson, I picked the two extremes because they were the simplest to illustrate. The lower Hudson, we thought the goal that it did best for was urban development. We want to utilize and promote development in urban cores. Investment was linked to public health, not necessarily to a clean trout stream. And they're not totally different goals, but you may be much more worried about pathogens here, whereas up here you're worried about stream clarity, things like that. Water quality impacts might be linked to coastal zones, and so the kinds of things that you're trying to prevent when it comes to your infrastructure may be qualitatively and quantitatively different than what you're trying to do up here. So just some conclusions. We used publicly available data. Certainly we weren't able to capture all the things we wanted to capture. But there actually were these watershed differences in a lot of different things. So growth being a pretty obvious one. Not all watersheds are growing at the same rates. Some aren't growing at all. Some have a lot of development potential, some don't. The water quality vulnerability was actually quite different by the way that we measured it in a lot of these different places. Things like investment capacity and the motivation to invest in water quality were different by some of these metrics as well. So again, getting into that idea that is water quality an important part of your local economy? Is it something that you're going to really identify with, or is it just something that should be good enough? Because otherwise, you've got a lot of other issues, like in New York City, for example. You just want clean water supply, otherwise the wastewater just kind of goes away. Different regions had different potential for consolidation of services. So sometimes you might have, for example, if this is the stream and it goes on for hundreds of miles, not hundreds of miles, but you can get it a couple dozen miles. You got one facility over here and one facility way over here. It's a little bit more difficult for these facilities to come up with some meaningful way to cooperate. But if you've got a facility here and a facility right there, within a mile of it, of the other facility, and that happens a bunch of times. There may be some really meaningful consolidation of services. maybe if both plants are sort of deteriorating at the same time, you may build one single larger plant. Good luck. But, you know, so what happened was a handful of times throughout the entire Hudson, there were a number of situations like this where plants were either within just shockingly close to each other, or 2 miles, for example. There are probably about a dozen cases of that. You can understand, for example, if maybe the Hudson ran right through it, and like one town is on one side, and like they're very disconnected for very practical reasons. We didn't count those. Like we assumed like, okay, there's a good reason for that. A lot of them really same community, no geographical divide of any significance, right next to each other. And you're like, wow, how did you mess that up?
Did you find out why? Like, why
Usually
it
no.
exists?
But we suspected that it's really, just a function of how communities grow historically. They started off over here, and maybe they didn't grow for a couple decades. This was really good enough. And then suddenly somebody built that development that had like 300 households. A new industry came to town or something like that, and they built a whole new plant. And now there's 2, and nobody remembers why. That type of thing. So it happens pretty frequently.
Yeah, like the village of Cuba Heights has its own wastewater treatment plant.
That's true.
Right, so Ithaca has 3 water supplies and 2 wastewater treatment plants. So we would be one of those if we were in this assessment.
What's the measure of how you're, can you describe what impacting downstream water quality means? How, is it and I think my follow-up question would be like, then if you line up all of the different watersheds, do you just see it increase with population size? Your impact increases with your population size? Or
So I think you're getting, like, what that had to do with, in a lot of cases, was whether or not a treatment facility was located directly on the Hudson.
Right.
So that when they discharge whatever, if they're a facility that discharges a lot of nitrogen directly into the Hudson, like that's going to pretty quickly make its way right to the coastal area, which has a known problem with nitrogen and things like that. So we saw that as being maybe a different issue in terms of not only, it's all important, but a different issue. Like, how would you tackle that? And is that different from some treatment plant that's rural, way off the main stem Hudson, in the middle of some place where whatever happens might be very local. So if you're releasing nitrogen into the stream, maybe it goes into a reservoir, or there's a lake right there, and maybe you get like an algae bloom that summer. But like that's a completely different story than like a coastal issue. So you might attack it very differently.
Yeah, and I thought you were, because it was interesting, I thought you were saying, because the big wastewater treatment plants on the Hudson, and especially if you include New York City, they're just like, they account for a huge percentage of the total waste that's being discharged. So if you were looking at that, if you were looking at, okay, we want to treat the maximum amount and prioritize that, you'd always be going for them. But then on the other hand, they're going into huge bodies of water. Whereas some of these smaller ones in the upper part of the watershed are going into smaller streams where they could potentially have a much larger impact.
For water quality. Yeah,
Even though in
that
the
was the
sum
hard thing
they
to
won't.
quantify.
Yeah. And
It's really hard to quantify. Like if you're in the
Yeah.
Mohawk, it might be a place where if you fixed one problem, maybe if you fixed one treatment plant, there might be 50 miles of stream now that actually there's nothing else really going into it. Like maybe you're going to really clean up those 50 miles of stream. But if you fix, no matter how good you make this treatment plant on the Hudson, I'm not saying I'm not trying to be defeatist, but it's just like the Hudson is going to have the exact same water quality issues, no matter how good you make that one plant. It's not until you fix all the plants, or in some way. I would think it would make sense from a watershed perspective to start at the outside and slowly fix things and maintain them, while you got to the ones that were more farther downstream, so that the problems upstream didn't continue. So that you were basically seeing those water quality benefits make their way downstream and slowly start to sort of attack the problem in maybe a more sequential, logical way. But then again, you run into all these issues of, well, that facility may be degrading now. It really needs funds this year. You can't wait for this big academic thought process of, we'll fix the outer ones first and then we'll come to the inside. So it's a big, messy problem. Those are some of the issues.
Brian, I thought you said also the way the Environmental Facility Corp ranks these, although they have all these different metrics that they use, that basically having an accepted engineering plan and having identified funding
Yeah.
just overwhelms all the other metrics.
It does. I mean, if you were to read the plan, there's a total of, let's say, about 200 points available to you if you can show that you're a community in need, the changes to your facility are really going to impact the exact problem that the state is concerned about. Maybe the state's like, oh, you discharge into this lake, and the lake really has a problem with nitrogen. And you're like, well, we're going to do this project, and it's going to really clean up our nitrogen. You'll get 200 points. If you can show that you've already got a loan from some other source, you get 1,000 points. 1,000 points. And like, okay, that's just their mathematical way of saying that if you can show us that you've got funding to push this project forward, we'll help.
Right.
And we'll help way before we help these other people who may not be able to prove quite so readily that they can manage that loan that they're about to get. Right? So it's really all about whether you can show as a municipality, can you manage this loan that you're about to take or not? And if you can show that, there's a lot of other things that don't matter, like whether or not it was a good project. So.
That's why you go from 2,100 something all the way to 1,000 something, and then off it jumps to
like 50.
50.
So, a lot of times the projects that are really demonstrating the most need, the most benefit to the water quality, maybe they couldn't secure outside funding, or they can't really show that they can handle that loan that year. They're not going to get the money.
Yeah, right, and I mean, sure, you could get into this more, but if you're a smaller municipality, you may not have the ability to float a bond, and almost all these larger municipalities, that's what they're gonna have to do, they're gonna have to float bonds, they go out on the bond market, or,
4%.
right, is that what they're getting right now, so, and.
4% of the utilities can actually float bonds,
Bonds, yeah.
in the US, and I'm guessing that the
But like
Hudson Valley is
Ithaca
not
can,
very different.
Ithaca can wastewater treatment plant, they can, and the town and the city can float a bond, but, probably, someplace like Ulysses, that'd be tough for them to do.
Yeah. I mean, it's hard because, New York doesn't have any there's no identified goal necessarily for, again, how would you assess these projects if there's no goal? You would just say like, well, this project looks good. I mean, if I'm reading their report, they're telling me they're going to impact something. That seems good. And I think actually it is a pretty good system. Like if you look at their priority, you can see how they're thinking, you can see that they incorporate all these really important things. I don't think it's a bad system. It's one of the things we suggest, again, like academically, which means mostly irrelevantly, what if they set aside some funding, some piece of the state revolving fund each year, and maybe a very small piece to begin with, and tried this approach? What if you took a small watershed and you said, hey, look, it does actually make sense to really start it, if possible, at the fringes, so that you can actually see that water quality benefit. Because a lot of times, again, like what's happening upstream, you can't escape what's happening upstream. So even if you fix something that's happening downstream, if the problem is coming from upstream, you've got the same water quality problem. But maybe you could make a goal and set aside some money to do this. I mean, of course, it's very difficult to experiment on that scale.
And the other thing they were interested in is if we could come up with how small was too small. Cause
they did want to know how small.
Too small. I mean, they kind of recognize that, but they have no way, they have no basis to justify
How small a plant?
a plant. Right. Because we were arguing it doesn't make sense to be funding, because there's a certain minimum cost to, to a wastewater treatment plant, and, so it's like, how many people do you have to have before you're serving before you can really justify? And a lot of what we see, and that was all that excess capacity is this kind of build and they will come view. A lot of municipalities think, oh, well, we'll put this in, and 10 years from now, we're gonna double the population.
Do you know, you'd mentioned that the Lansing project maybe got voted down?
Yeah.
Is that the, sort of the
That was a
incentive
classic,
behind that?
yeah, that was a classic kind of thing, but there you had a much more active community. You had some Cornell professors, so on, who were willing to kind of go to the town meetings, but, there, well, I think it was 160, households were gonna get served, and, was that it? I think about
Yeah,
160,
160
and
more.
a school. And then, and the Cargill gave them the land, they had that advantage, the Cargill was giving them the land. But then the minimum cost was over 10 million. And so when they kind of did the numbers, and there was this group of developers downtown and the town board, oh, this is great because Lansing, which is the town, it's not the village, it's the town of Lansing, there's a village of Lansing, which is where kind of the mall is all over there. So the town is way further out, kind of go to Rogues Harbor right there. And they were like, oh, we're gonna be a whole new little,
I
right?
just
Cape
remember
Cod,
seeing-
the next
yeah.
Cape Cod, that's
The
what they
next
said.
Cape Cod,
That's
that's
what
how
they
they were
said.
envisioning
Not,
it.
I'm not making this up. I went to their town meeting.
Yeah, that's what happens. And we'll have coffee shops and all this kind of stuff, and this'll be, it's like you look out there.
I might go to Rogues Harbor.
But I knew about it just because I saw lots of.
The
summer,
signs.
the say no to the sewer.
Yeah, so then they said,
signs.
oh, so then it became clear, they couldn't spread the 10 million over the 160 people, and so, so they had to have a kind of inner circle, and then an outer circle who wasn't gonna ever even get paid, but they, or get this treatment, but they were gonna have to pay. And so then finally they were like, what the heck are we doing this for, so. But they still have, cause I saw the town planner.
Yeah, I was just gonna put in a small plug for, I mean, I think along the themes of complexity and stuff, it's not that the DEC hasn't thought about some of these things. I mean, they're smart people, they know some of this stuff, like, could be done better, like, but when we talk about, like, well, developers have a say, you know, and politicians have a say, and people in town halls have a say, and a lot of times it's like either retired people or so, they come in because they're the ones who actually come to the meetings, you know, and well, it's sort of true, you know, it's like it depends on very different flavor of conversation if all you get is sort of people who've already made their money or rich people or whatever, you know, retired people.
Right.
So they just have a different perspective and they're going to want different things, and so it's very hard to just say, well, we've got this system, we think it's going to work great, and here we go, we're going to do it. Because as soon as that happens, immediately all these other perspectives come in. And what comes out at the end of the day looks like the intended use plan, which has some things that make sense and some things that I'm not sure it makes total sense, but
And also
that's the reality of how things end up happening usually.
and it's not coordinated on a regional scale, so but
Because there's no real incentive in New York to do it.
in New York, because we're a strong, I think we've mentioned this, we're a strong home rule state like Massachusetts, but if you were in like Maryland or Virginia, then these decisions would be being made at least at the county level. So they wouldn't be being made at the municipal level. So you wouldn't end up like Tompkins County having, 11 police forces and.
You'd still end up with the issue of like a county that's a bigger unit, but it may not be following the watershed lines.
Right.
And if you're regulating water quality, maybe we should be looking at where the water goes.
Right.
But then it becomes very difficult from a jurisdiction point of view, like how do you get people to really make decisions on a watershed basis when that's not the way they've been, they're not set up to make decisions that way.
Right.
Although the state could be. So, yeah, they won't.
So what are the other states doing? Sort of how many states use this sort of like municipality-based, point of views approach? And what if they don't? What are they doing?
Almost all states that actually have primacy and run this program use that integrated priority system. And they won't have the same priority system that New York has. There's a review of that out there if you ever wanted to look at it. And you can see that they can be quite different, but they all sort of follow that integrated priority system model. What was your other question? The last question?
Yeah, I mean the states that don't, what do they do?
Right. Some states might actually have EPA run their program for them.
But does EPA follow the same sort of like plant by plant evaluation?
Yeah, it'll all be a ranking system essentially.
Yeah.
And with the caveat, it's written in there that the funding agency doesn't actually have to listen to the recommendations of the priorities. So they don't have to actually.
Environmental facilities court,
Yeah, like,
right.
at least that's for New York at least. They don't have to do, like if they say, well, this is the most important project, you know, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They don't have to do that if they don't want to.
And the head of the environmental facilities court is a political appointee. So,
So. All right. Well, if you want to stay and chat, that's cool. But we're going to actually end on time today.
All right.
So thank you very much.